Hi, in this video I'm going to talk about what are functions in Python. So functions are very useful while doing data analysis because we can use functions to automate tasks. So whenever we need to sort of reuse Python statements, we use functions instead of repeatedly using Python statements. So this is very helpful in automating certain number of tasks. So I'll give an example. Let's say we want to multiply two numbers. So instead of simply multiplying it once, and if we need it, we do it again. We simply write a function, and whenever we want to multiply numbers, we simply call that a function. So here is this simple example. I've created the function mult, which will do multiplication and which is going to give us the product of the multiplication of two numbers. Okay. How do we define a function? We define a function by the keyword def and then the function name, and then we can have parameters. We can have as many parameters as we want, and then we will in the function we will write like what exactly do we want from the functions. So here we want the product of the two numbers, so that's what it is going to return. So functions, most of the times it's going to have a return statement, um, and it can have more than one return statement, and the return statement will provide us the output from these functions. Now we have defined it. Okay, so let's define it, and then now we can call it. Okay, so how do we call it? We simply write the function name and give us the values. Okay, so we want to multiply 3 and 4. Okay, so now we have 12, right? Let's say we want to multiply 120 to 134, right? So we get the product of these two numbers. So it's very helpful to automate, right? It's a simple task, but instead of just multiplying two numbers, writing that statement again and again, we simply have written a function that takes two values or two integers and give us the product of those two integers. We can use multiple return statements instead of just one that we've just seen in the previous example. So here is this example where we have multiple return statements. So I define a function, test. It has got three parameters. I'll use a conditional statement. If g is greater than 1, then return x plus y, else return x minus y. Okay, so what it does is it takes three values x, y and z, and based on the values that g takes, it is either going to return x plus y or x minus y. We just run it, and let's let's run this function once. So it's test. So let's say 1 2 3. Sorry. So what are we expecting? We are expecting okay, the g is greater than 1. Yes, that's true. G is greater than 1. So return x plus y. So 1 plus 2, which is 3. That's right. I was thinking it maybe there is something wrong with the function definition, but that's true, right? There's nothing wrong. Let's use another one. 2 3 6. Okay, so here also, or maybe 2 6 1. Okay, so g is 1 here, right? So what we are expecting is that this part of the function will run, right? X minus y. So we should be getting something like minus 1, and that's what we get, right? Okay, so now we use slightly more complicated functions. So here is this function. We define a function and we name it as func, and without the parameters. Okay, so we also can have functions without parameters, and but we can you can also return something without having a parameters. That's also possible. Okay, so what do we do here is that we simply use a loop, okay, for loop, and then we simply append the values from this for loop to a list x. Okay, so that's very simple rotations. Now one thing to learn here is that we have defined this list variable x, right? That's within the function and it's local to the function. It cannot be used outside of the function. Okay, so that's one thing to, so if you define a variable inside the function, then it is local to the function. So that one thing to remember. Okay, we can return multiple values from a function. That's very interesting. So instead of just one value, we can return multiple values. That's possible. Here is this example. We define a function, we just use the same name. We can use any other name. So x equal to 3, y equal to 4, z equal to 6, and then we return x, y, z, all three of them. That's possible to return. We run it, see the output is 3, 4 and 6. Alright, so slightly more complicated example where we are going to use a function to remove or to clean the data. So here is the data. We have a string state. It has got different states of the United States, Alabama, Georgia, Florida, but you can see that it's not in proper order. That means sometimes we have extra space, sometimes we have hash, sometimes you have um, all in small letters. That's not how we want. We want spaces to be removed, special characters to be removed, and then first name or the first letter of each word in the state name should be a capital. Okay, so that's what we want. So how do we do that? Well, we write a function clear underscore string, and we you pass on this particular string as the parameters, and then the results are going to be saved in the list result. And again, it's a local variable. Write a for loop, and for every value, so every state within that string, it is going to simply remove this the quality issues from each of these strings, each of the string parts, right? For example, for the first part, Alabama, it is going to remove the spaces. Here it is going to remove the special characters, which is the exclamation mark. Here it is going to remove the special characters and also the spaces, and so on. So we use some of the inbuilt functionalities of Python. So here the so strip function, which is an inbuilt function, is going to strip the spaces. Then we import re, which is going to remove all the special characters. So we simply write re.solve and provide the value, and it is going to take the special characters away from what is there in the value. And then we use title function. Title is used to sort of make sure that the first name is caps and then rest of all characters are all in small. So that's the way it's. So we have simply automated this. We can do it once, and then if some other string comes, you'll have to do it again. And the beauty of writing a function is that you just write the rules once and use that function whenever you have a new string. So it reduces the efforts significantly. So we have run the function. So let's now use it. Okay, and you can see we have a much more cleaner data, right? Spaces have been removed, special characters have been removed, right? And all of these names starts with a capital letter followed by the small letters. So that's perfect. Functions can be used as argument as well. Okay, one function name can be used as an argument in other like functions or even in writing loops. Same example we'll do with some what do I say, some inbuilt functions already there in Python, something that we can use to remove to remove spaces and special characters and so on. So we define a function remove punctuation marks, and what it returns is that it takes a value, it removes special characters and spaces from the values. Okay, and then what we do is that we take each part of the string and then pass through a function called map, which is what it is going to do. It's going to use the function that we have written and use the string and will return the values. And what it's going to return? By removing the special characters and spaces. So remember one thing here, states is just the string that we just saw, and remove underscore punctuation is just the function that we just defined. So function is now a parameter to the another function which is an inbuilt function called map, and you can see the results. So it's the same result that we received even last time around. All right. Another important thing is that instead of just values, you can also use some variables which has got some values as a parameter. So here in this example, we're defining a function which will add two numbers. So the add function is it takes two values, two integers, and it returns the sum of these two integers. Okay, so here we use it and we get the values, right? But instead of providing the integers as the parameters, we can also use a variable, a global variable, and use that variable as a parameters. For example, we define y equal to 4, and the way we call the function is that we provide the first integer, and instead of providing the value of the y, we simply provide y. In that way also we can call we can call a function. We can also call even by two variables. That's not an issue. Let's define g equal to 5, and instead of 2, let's say we simply want to add g and y. So the values from y and g are going to be used in the function, right? It gives us 9. Alright, now that we have learned a bit about functions, I'm going to give two exercises. One I'm going to do it, and the other one I'm going to give it to you for your practice. So here is this example where we are trying to find out the factorial of a number. So factorial of a number is just that it's a product of the numbers multiplied to its preceding numbers up to 1. For example, the factorial of 2 is just that 2 multiplied to 1. Okay, factorial of 3 is just 3 multiplied to 2 multiplied to 1. Okay, so in other words, we can say that factorial of 3 is 3 multiplied to 2 of factorial. So factorial is, we just use exclamatory marks to sort of denote that. Or in other words, we can say that factorial of x is nothing but x multiplied to factorial of x. Okay, so that's basically the logic. How do we automate this to a function? So here is the way we do it. So we define a function fact which takes a value of x, which takes the parameter x. That means the integer or the number for which we want to compute the factorial, it's going to take that as the parameters. If it is equal to 0, then it returns 1. That means the factorial of a negative number is not possible, and the factorial of 0 is 1. But if it is not 0, so it has to be greater than 0. It has to be a positive number. If it is greater than 0, then return this number multiplied to factorial of that number minus 1. Now you might wonder, how does it work? Well, this is called recursive calling, wherein, let's say we use, fact equal fact of 5, factorial of 5. Okay, so it is greater than 0, so it comes here. So 5 multiplied to factorial of 4. And what is factorial of 4? It is 4 multiplied to factorial of 3. What is factorial of 3? It is 3 multiplied to factorial of 1. And what is factorial of 1? It is 1 multiplied to factorial of 0. And what is factorial of 0? It is 1, right? So from there it will simply get calculated recursively, and it's going to give us, right? So that's the way it works. And we run it, and then we can compute now factorial of anything. We can check this whether it works. Factorial of 3 should be 6, and we should be getting 6. Factorial of 4, it should be 24. Yes. Factorial of 5, 120, right? So you can simply do that. The next thing you can I would highly encourage you to do is to write a function for Fibonacci series. Okay, so what a Fibonacci series is something that you can see just each number in a Fibonacci series is the sum of its past previous two numbers, right? You can read about what is Fibonacci series on Wikipedia and write a function which will given the series length, it is going to give you the entire series as the output from the function. So please go ahead and please write this function, and it's going to be a good practice. Thank you.